Hi, this is Brian Rush with the Security Software and Processor Group, and I'm here to talk to you about the MAX78000 Artificial Intelligence Microcontroller with Low Power Convolutional Neural Network Accelerator. Let's start by talking about the challenges of implementing AI at the edge. This AI, really just machine learning, is a powerful pattern recognition process. It can enable machines to hear, see, and sense complex patterns. So the sensors that we're using are cameras, microphones, inertial vibration sensors, and similar types of sensors that produce either a frame or a continuous stream of data. Executing AI at the edge, really doing an insight, taking that large amount of data and just producing some higher level of information in a much smaller form of data, such as, is this John in the picture? Um, what sound was just made? What word was just spoken? Things like that. They require lots and lots of matrix multiplications. And because there's so much data involved, they require lots and lots of memory and compute horsepower. And this, of course, means lots of power and time and cost. So if we look at some of the options, you can't optimize all three of those at the same time. So if you want to optimize for power, you want to go to a really low power microcontroller, such as a Cortex M4. But you sacrifice speed and complexity. There's some limit to how complex the jobs you can run. If you optimize for speed, your options are like a GPU or an FPGA or a real fast, high-speed microprocessor. And you sacrifice cost and power. And if you optimize for cost, you're really back at doing some kind of a small microcontroller at the sacrifice of speed and complexity. So what we really need is something else. And so one of the things in common with all the things we talked about, probably except for the FPGAs, is that they are running code. And we really need a true edge IoT device that can practically see without requiring a power cord or big expensive battery. And that's where our accelerator comes in. When you look at the block diagram of the MAX78002, you notice that one half looks just like a microcontroller. So we're over on the left, we've got memory, both flash and SRAM. We've got timers, we've got security, lots of interfaces and GPIO. We even have some built-in power management with a SIMO, or single inductor multiple output DC to DC converter. And we've got an ARM Cortex M4F running at 120 megahertz and a RISC-V core. This is a smaller core, 32-bit integer only. And all of this runs sort of the application side. It also feeds data to the CNN accelerator. And the departure here on this part from the MAX78000 is really the memory sizes. We've got a MIPI CSI2 camera interface in addition to the parallel camera interface. But it's really over on the CNN accelerator side. This CNN is running 4 times faster, and it has a larger memory, so we could run about a 4 times larger model. So it still has 64 processors, but there's 2 megabytes for the kernel memory, and then 1.3 megabytes for the data memory, and it will support 128 model layers. The MAX78002 benefits and features are similar to the MAX78000. However, it can run a much larger model, and it can run it a lot faster. And similarly, the MAX78002 EV kit has many of the same features as the MAX78000 kit. However, it does expose more of the port pins. allows more connectivity on I2S. So we're supporting both the parallel camera interface and CSI camera interface. We've included the power monitor as well. The MAX78002 enables AI at the edge by addressing the three main challenges: power, speed, and cost. For power, it's accelerating a CNN computation with 100x less energy per inference. In terms of speed, it's running well over 100 times faster. And in terms of cost, it's slightly more expensive than a microcontroller, but it handles much more complex insights and near the performance of a GPU or FPGA, but at a much lower cost. If you're ready to learn more, there's three things you can do. You can acquire an EV kit. You can explore the development tools and documentation on GitHub, or go to our landing page where you'll find the datasheet and other options. Our recommendation is that you start with GitHub, and you can look at the tools that are freely available that support both the MAX78000 and MAX78002, as well as the example models. And then we're very eager to have meetings set up with the customers who are interested, and we can help set expectations and figure out next steps. Thank you very much.